An electric motor of power 100 watt is used to drive the stirrer in the water bath. So there is a stirrer who is working like stirring the water. If 50% of the energy supplied to the motor is spent in stirring in the water, that was the primarily usage of that. So whatever energy we are supplying, only 50% is getting used in stirring the water. Calculate the work done on water in 1 minute. So we have to calculate how much work is done on water in 1 minute. So let's understand first thing. We know that power is work done by time. As the power of the electron motor is 100 watt, it means the motor is doing work of 100 joules in 1 second. See, that is why understanding what W means is important. It is just a shorthand of joules per second. So 100 joules of work is done per second. So that gives us more intuition about what we are talking about here. So the motor is doing this much of work, 100 joules in 1 second. In 1 minute, the work done will be this much, 100 joules into 60 seconds. So this much work is done in 1 minute. But here is a catch of percentage when they talk like not all the energy is going into the stirring into water, but only 50% of this work is spent in stirring water. Rest of it is spent maybe in heating, maybe in some friction, right, with the mechanical parts, which is common in home appliances. So we need to see how much energy is going in stirring the water, and that is only 50%. That is what in the question they mentioned. So we just have to multiply 50%, and that is 0 0.5. We always we need to know how to deal with the percentage. So if they are saying 50% is used, it means half or 0 0.5 of the total work done or energy supplied is used in stirring the water. So here, if it is 90%, I will use 0.9. If it is 10%, I will use 0.1 likewise. So 0 0.5 into 6,000 is just half of that, which is 3,000 joules. So 3,000 joules of work is done in 1 minute. Remember, this is not the power. So it is the work done in 1 minute. That is what they have asked. Okay, let's go ahead. Question number 7. A man exerts a force of 200 Newton in pulling a cart at a constant speed of this. Calculate the power spent by man. So we should know the formula of power in terms of force and velocity. See, the power formula is, if you don't remember this, we know the work done formula, which is force into displacement. Force into displacement. Now see, the formula of power is work done divided by time, right? So if this is the work done, if we divide it by time, if you see this expression, what is this? This is displacement by time. How quickly the displacement has been made. So what this is velocity. This is velocity. So our power expression, which is work done by time, becomes force into velocity. So this is another formula. You can also derive it or remember it, right? So anyway, so power is force into velocity. Force is this much straight away, and they have given us speed also, constant speed of 16. So we will get 3,200 joules per second or watt as an answer. Let's go next. Question number 8. The work done by the heart is 1 joule per beat. Calculate the power of the heart. If it beats 72 times in 1 minute. So if you want to calculate power, remember the one thing is it is measured per second. So that is the intuition. So they have given in different times and we have to calculate like how much work is done per second. So let's see how we can go about it. We know power is work done by time, but here work done is given in terms of beats. We need to find relation between beat and seconds, right? Because we want to get this power which is in terms of seconds. So whatever they have given in beats, we need to calculate how much one beat is in 1 second. So let's go for that. So number of beats in 1 minute is 72 beats. They have told beat 72 times in 1 minute. So we wrote that. And then Okay, 1 minute means 60 seconds. It beats 72 beats, or in 1 second, how much it will beat? 72 by 60. If you solve this, you will get 1.2 beats, or you can just simplify it in a fraction. So we will say 1.2 beats. So in 1 second, there are 1.2 beats. Or we can say, we can just put this 1 by 2 this side, and we can say, so 1 beat is actually is a measure of time, and it is 1 by 1 by 1.2 second. So this was one thing we did here. 1 beat is equal to this much of second. And now we can calculate. See, the power given in terms of beats, power is 1 joule per beat. This is what is given to us, that 1 joule per beat is the power. But now we know we can convert this, because we want not a beat, we want in terms of seconds. And we have already driven the relation between the beat and seconds. So we'll put it here. 1 joule divided by 1.2, and then 1.2 joules per second, or 1.2 watt. So this will be our answer. The heart is also working like a machine, and it has some power spending, power consumption, and that is 1.2 watt. Let's go to the next question. Express 5 kilowatt hour in joules. Remember, this is the unit of work energy. This is not of hour time unit. So that is a major confusion. Seeing hour, we think like it is a measure of time. No, it is the measure of energy. And we have to convert into joules. And doing it will be very simple. If we understand what watt stand for, what hour stand for, what kilo stands for, we'll be very easily able to do it. So see what I'm doing here. Let's see what 1 kilowatt hour means. Okay, 1 kilowatt hour. So we will just multiply at the end with 5, and we'll get the answer in joules. So 1 kilowatt hour is kilo. I'm expanding watt joules per second, and then I'm putting here hour. Now I'll expand different things. Kilo means 10 to the power 3. It's a prefix. Joule per second multiplied by 3600. How I got it? 60 into 60. 60 minutes for the 60 seconds. 60 by 60 is 3600. Now if you see, the seconds will get cancelled, right? I'm keeping the units. So seconds will get cancelled. What will be remaining? Only joule. So if you solve it, you will get this expression, because only joule is remaining. So even when you are in confusion whether this units belongs to what, if you'll just expand them, you will see some units will be cut, and what it represent is joule, which is a unit of energy. So that's how also you can think about these kind of units if in case of confusion. Okay, just after that, we just multiplied by 5, and we'll get the answer. 1.8 into 10 to the power 7 joules. So let's do the last question. The energy of an electron is this much. Express it in electron volt. So it's just a unit conversion question. Let's see. We use energy units of electron volt when we are dealing with atomic scale particles like electrons. So this is a very small unit of energy. We use it when we are dealing with protons, electrons, atoms, when we talk about this much of energy. But anyway, we should know that 1 electron volt is this much. 1 electron volt is 1.6 into 10 to the power minus 19 joules. So remember that. So 1 joule will be, in terms of electron volt, will be this 1 by 1.6 into 10 to the power minus 19. But remember, we are converting this because we want to convert this, and instead of joules, we want to put electron volt. So that's why this gives this. I know 1 electron volt is this, but I want to know what 1 joule represents, right? So this way has to go down. So that's why it has come 1 by 1.6 into 10 to the power minus 19 electron volt. So the energy of the electron given is 4 into 10 to the power minus 19. We'll use this equation. We'll keep this 4 point into 10 to the power minus 19, but instead of J, 1 joule, we will just write what 1 joule stands for. It stands for this much of electron volt. And then you have to do simple math, and you will get the answer of 2.5 electron volt. So this will be the answer.